This is the summary for Lesson 13, Solving Systems of Equations from Unit 4. And in this summary, the authors are describing why a solution to a system of equations is the intersection of the graphs. And so they start out with telling you that in a system of equations, so here's the equations right down here. So y is equal to some stuff, and y is also equal to some other stuff. And I think this is easier, at least it's easier for me to understand in the context of a story. So the story is that two sisters are riding their bicycles away from each other and they're starting at their house. And so y is going to be the distance of the house from a fountain. So that distance is not going to change. It's the house is in its spot and the fountain is in its spot, and that distance is going to be y. It's not going to change. The fountain is going to be at 0 miles. So how far is the house away from that fountain? We'll figure that out in a moment. But also, as the sisters ride their bikes, the speed at which they ride is different, but the time at which they ride is the same. So this is y is the same, the distance of the house from the fountain, or the location of the house, and x is going to be the same. That's going to be the time that they ride their bikes. And the distance traveled is going to be different. So the speed is different, and the distance traveled is different because they're riding at the same time. They're riding at different speeds. They're going to travel different distances. But this x value is going to be the same. It's the same amount of time that they're riding, and the house is the same distance away from the fountain. So y is the same for the system of equations, and x is the same for the system of equations. So it's the same time. So down here we know that the value of y will be the same for both equations because it's the location of the house. That's not changing, it's not moving. So both sisters are starting at the house, and it turns out that some stuff, so the right side of this equation, is equal to some other stuff, which is the right side of the other equation. Now this bothered me for a while. How could some stuff be equal to some other stuff? But the context of the problem helps me understand that. This is a graph of the system of equations so I can talk about the context. So this is one equation, y equals 2x plus 6 for sister number 1, and sister number 2, her equation is y equals a negative 3x plus a negative 4. So these are the two graphs. We'll go into this in more detail later, but it helps talk about the story, the context of these two equations. Notice that when they both start, they are 2 miles from the fountain. So here's the fountain, and the house is 2 miles away. So 1 mile, 2 miles. And the sister that's riding north, sister number 1, she's riding at a slower speed. So she's not going to go as far. So she ends up 4 miles, riding 4 miles. And she ends up 6 miles from the fountain. So she's farther from the fountain, even though she's riding at a slower speed. And sister number 2 is riding faster, riding at 3 miles per hour, but in the opposite direction, so south. But she rides farther. She rides for 6 miles, but ends up closer to the fountain because she's starting out 2 miles north of the fountain. So notice that this 2 hours times 2 miles an hour, that's 4 miles that she travels and ends up 6 miles from the house for sister number 1. So that 4 miles that she travels plus 6 miles from the house, that's a total of 10 miles. And this sister number 2 is traveling for 2 hours, rides for 6 miles, but ends up only 4 miles from the house. So that's 2 times negative 3 is negative 6 plus a negative 4 miles from the fountain. So this has a magnitude, a size of 10 miles, but it's a negative 10 miles. Sister number 1 has a magnitude or size of 10 miles, but it's a positive 10 miles. The only point here is that those distances have this equal magnitude. Now the signs are going to change when we actually work through the algebra because this is a negative time, so it's going to be a negative 2 hours. But for the purposes of showing you why the right side of this equation is equal to the right side of this equation, in other words, the magnitude of those, of the right side. So forget about the sign for a moment. they are both 10 after 2 hours. When we work through the algebra, let's just to prove it, just to show you, let's use x equals -2. So -2 times a +2 is a -4. 6 plus -4 is 2, so y is equal to +2. In this equation down here, a -2 times a -3 is a +6. A +6 plus a -4 is also +2. So this house is at y equals 2. So you can start to get an idea that because of the location of the house, slower speed, farther from the fountain. Faster speed, closer to the fountain. So that's why some stuff, this side, can be equal to some other stuff, this side. So think of it as the location of this house compensates for this slower speed, farther from the fountain, and for sister number 2, her faster speed, she actually ends up closer to the fountain. So that makes this side of the equation equal to this side, the right side of the equation for number 2, for sister number 2. Also notice that the time that they travel is equal to each other. So x is going to be equal, and the house, the location of the house is the same for both of them. So x is going to be equal for both equations, and y is going to be equal for both equations, which turns out to be the intersection of both equations. At time 0, the two sisters will be 10 miles apart. So they start at their house, and then when they've traveled for 2 hours, they will be 10 miles apart, and that's going to be time 0. So that makes the time when they leave the house a negative time. It's 2 hours before they are 10 miles apart. So at time 0, they're 10 miles apart. Sister number 1 is 4 miles north of the house. It's also 6 miles north of the fountain. And sister number 2 is 6 miles south of the house. So 6 miles south of the house and 4 miles south of the fountain. Sister number 2 also passes the fountain 2 miles south. Sister number 1 travels at 2 miles per hour. So 2 miles per hour times 2 hours puts her at 4 miles from the house, right up here. And sister number 2 travels at 3 miles per hour, but it's a -3. She's traveling in the opposite direction. But a -3 times 2 hours is a -6 miles. So 6 miles south of the house and also 4 miles south of the fountain. So you can ask some questions. How many hours to reach 10 miles apart? So how long does that take them? They're traveling at a combined speed of 5 miles per hour. This 2 miles per hour plus this 3 miles per hour, although in the opposite direction, that combined speed is 5 miles per hour that they're traveling away from each other. So to reach 10 miles, well, 10 miles divided by 5 miles per hour gives you 2 hours. What's the order of the sisters, the fountain, and the house in miles? So sister number 1, the house, the fountain, and sister number 2. So now we can set these two expressions equal to each other. The time is the same, so the amount of time it takes them to travel to 10 miles apart is the same amount of time, and y is the same. So the house is not moving. That house is at this point right here, which is y equals +2. So it's 2 miles from the fountain. So you can set these two expressions equal to each other because y is equal, and also x is going to be equal. So you're going to solve for x and find out what that value is when they are both at the house. So algebraically, I have a habit of changing whenever I see subtraction, I always change it to addition. So this is subtracting a +4. That is the same as adding a -4. So use the inverse operation. The inverse operation of subtraction is addition, and use the additive inverse. The additive inverse of a +4 is a -4. So adding the opposite value. It's the same down here. This is subtracting a +4. I'm going to change that to adding a -4. It just helps me keep track of the signs of the numbers. And so you have some choices. The authors chose to add 3x to each side to do the algebra. So this is a -3x. If I add a +3x, that's adding the additive inverse. This will equal 0. So add a positive 3x to this side. 2x plus 3x is equal to 5x. I chose to add a negative 2 to each side. So I'm here at negative 3x. If I add a negative 2, that's the additive inverse of a positive 2. Add them together, you're going to get a negative 5x. So here it's a positive 5x, and over here, the way that I chose to do it's a negative 5x. You should try both ways. You should get used to seeing these in both ways, because you'll do them different ways depending on your comfort level. And so the y-intercepts are 10 miles separate. So the authors chose to subtract 6 from each side. So add 6, then subtract 6. So this is a negative 4 minus 6. I chose to add a positive 4 to both sides. This is negative 4, add a positive 4. So 6 plus a positive 4 is going to equal a positive 10. And so I end up with a negative 5x equals 10. The authors end up with 5x equals a negative 10. It's going to give you the same answer for x. X is equal to a negative 10 divided by 5 equals negative 2, or x is equal to a positive 10 divided by a negative 5, and x also equals negative 2. And just showing you with the expressions the way that I did it, I just did it the opposite way the authors did it. So this is 6 minus negative 4. So I chose to subtract this negative 4 before I chose to add positive 4. Again, these are all the same. It's the same thing, just changing the signs in an ordered way, which you can do. So 6 minus a negative 4 is the same as 6 plus a positive 4. That equals positive 10. And a negative 3 minus a positive 2. So negative 3 minus a positive 2 is the same as a negative 3 plus a negative 2. Same thing. And you get negative 5 on this side. So positive 10 divided by negative 5 equals negative 2, 2 hours before they reach 10 miles apart. So basically you're going to use these two expressions, they're 10 miles apart, set them equal to each other. You're going to calculate how long it takes them to meet at the house going backwards in time. So for both sisters, they each ride their bicycles for the same amount of time, for 2 hours. So if you go backwards in time, so 2 hours before they are 10 miles apart, you wind up at their house. That house is in the same position. Y equals 2 miles, in my example, 2 miles north of the fountain. So when x is negative 2, y is 2 for both equations. So for both sisters, the house is the same distance from the fountain. Y equals 2 miles. They travel for the same amount of time. That's x equals 2 hours, but that's a negative 2 hours. It's before the fountain, before they are 10 miles apart. So again, when the time is 2 hours before they are 10 miles apart, or at the time that they leave the house, that house doesn't change. For both sisters, it is 2 miles, and in this case, 2 miles north of the fountain. So when x is equal to negative 2, so this is 2 hours before they are 10 miles apart, y is equal to 2. So 2 times negative 2 is negative 4. 6 plus negative 4 is equal to 2. So the house is 2 miles north of the fountain. So in a system of linear equations, there are 3 possible situations. One is that there are no solutions to that system of linear equations. A second is that there's exactly one solution to that system of linear equations, and that's the example in the summary, a single solution. And finally, there can be an infinite number of solutions to that system of equations. So no solution is when the lines are parallel. So the lines are parallel, they never intersect, meaning that there's never a point in which the value for x is the same in both equations and the value for y is the same in both equations at the same time. Exactly one solution is when the lines intersect at a single point. That's our example in the summary. And finally, if it's two different equations for the same line, basically it's the same equation, same line, there will be an infinite number of solutions. Whatever you choose for x for one equation, you're going to get the same value of y for both equations. So x and y will be the same, whatever you choose. For this system of equations, the x-coordinate to the solution is a -2. And that's a little bit tough to deal with time, where x is negative. So if you look at the x-axis, time is negative at the solution. So that means you have to go backwards in time. Something's happening before the event that you want to look at. And in this case, that event is, when are those two sisters 10 miles apart? So to make it a little bit easier to create a story in context, I moved the entire system over to where the solution, the x-coordinate of the solution, is 0. And you can also see that the y-intercept in this case is 2. So the intersection of these two graphs is at y equals 2 and x equals 0. And the story is a little bit easier to see. So the two sisters leave their house. When are they 10 miles apart? How long does it take them to travel to be 10 miles apart? So this sister travels 4 miles and is 6 miles away from the fountain, and this sister travels 6 miles and is 4 miles away from this fountain. And at that time, they are 10 miles apart. So a little bit easier to talk about the story in that way. If you move the whole system further along the x-axis, and so now the x-coordinate of the solution is a +2, and y is still +2. And actually y, the y-coordinate, the house, is still 2 miles from the fountain in every example. But now x is equal to +2. So now you can look at it as the two sisters are 10 miles apart, and they're traveling home towards their house from opposite directions. How many hours will it take them to reach the house? And the answer again is 2 hours. But now that story makes a little bit more sense, a little bit easier to see what's going on. So this sister is 8 miles from the fountain, 6 miles from the house, and this sister is 2 miles from the fountain and 4 miles from the house. And so the total distance that they are apart is 10 miles, and this sister travels 6 miles to reach the house. This sister travels 4 miles to reach the house. A little bit easier to talk about the story with the solution being positive for both the x-coordinate and the y-coordinate. This is the same graph as we started with. I just cleaned it up a little bit. And I looked at this and I noticed that the two sisters, as they travel towards the house, 2 hours before they get to the house, they're 10 miles apart. But this sister is 8 miles from the fountain and 6 miles from the house. This sister is 2 miles from the fountain and 4 miles from the house. And then it shifts. This sister is now 4 miles from the house and 6 miles from the fountain. And this sister travels past and down here 2 hours after they leave the house. This sister is now 4 miles from the fountain and 6 miles from the house. So it switches. And I was wondering why that happens. So I put together a series of graphs where I shifted the time over 1 hour each time. So I just shifted that time to the right 1 hour each time. So as I shift it to the right, 1 hour, 1 hour, 1 hour, 1 hour, and so on, then I started to look at what changes and what remains the same. And you'll notice that all of the y-coordinates remain the same. And that makes sense. You're just shifting things to the left or the right. You're not shifting things up and down. So if we start out here, this sister is 8 miles from the fountain, 6 miles from the house. And that remains the same throughout. 8 miles from the fountain, 8 miles from the fountain, and so on, all the way throughout. And this sister down here is 2 miles from the fountain and 4 miles from the house. And again, that remains the same all the way throughout. After they pass the house, this sister number 2 actually, is now 4 miles from the fountain and 6 miles from the house. And sister number 1 is 6 miles from the fountain and 4 miles from the house. So it shifts, it switches. And that makes sense because as this sister travels towards the house, she's traveling at a rate of 3 miles each hour, but it's 3 miles south, so it's -3. In 1 hour, it travels 3 miles. 1 hour, it travels 3 miles. Reaches the house. That's 6 miles in 2 hours. So another hour traveling past the house, goes past the fountain, travels 3 miles. Another hour travels another 3 miles. So 6 miles past the house, and this is 6 miles before the house. It's the same over here. This sister travels 2 miles towards the house, another 2 miles towards the house, and reaches the house in 2 hours because she's traveling at 2 miles for each hour. Reaches the house, travels past the house, travels 2 miles, and another 2 miles. So in 1 hour travels 2 miles, and another hour travels another 2 miles. But what changes is the y-intercept and, of course, the time. So the time is shifting to the right. But notice what happens to the y-intercept. So let's go back here to the beginning. So this y-intercept is at 6 miles from the fountain. This sister rides at 2 miles each hour. This sister is 6 miles from the fountain after she's passed the house in 2 hours. So 1 hour shift to the right, she's going to be 4 miles from the fountain and 2 miles from the house. Another shift to the right, she's going to be actually at the house and 2 miles from the fountain. Another shift to the right, she's now at the fountain but 2 miles from the house. So this is changing by 2 miles each time. So now she's -2 miles from the fountain, -4 miles from the fountain, -6 miles from the fountain, -8 miles from the fountain, and -10 miles and -12 miles. The other sister, so if we start over here, she is 23 miles away from the fountain. And every hour she gets 3 miles closer to the fountain. So it shifts from 23 to 20 to 17 to 14 to 11. And now we're on the graph here to 8 miles from the fountain. Shifted another 3 miles is 5 miles from the fountain. Another 3 miles is 2 miles from the fountain. Another 3 miles. She actually has now gone past the fountain and is a -1 mile from the fountain on the other side, so south of the fountain, and 4 miles south of the fountain. So what's shifting is the y-intercept, and the time. What's staying the same is the y-coordinates every single time. Notice that the house and the fountain always remain the same, because that house is always 2 miles from the fountain, and the fountain is the point from which everything is measured. So the fountain is always at 0. It's always 0 miles from the fountain because it's the fountain. The house is always 2 miles from the fountain because the house is 2 miles away. As the girls travel, they are different distances from both the house and the fountain. It would be useful to pick a couple of these graphs and have students tell the story for each of those graphs. For example, if I took this graph and told the story of traveling towards the house for each sister, I can begin by asking the question, where is each sister at time 0? So here's time 0, and so each sister at time 0, sister number 1 is actually at the fountain at time 0. So how many miles is she away from the fountain at time 0? She's 0 miles away from the fountain. Sister number 2 is 5 miles away from the fountain at time 0. They're going to meet 1 hour after sister number 1 passes the fountain. So where is each sister 1 hour before time 0? So if you go backwards in time 1 hour before this time, where sister number 1 is at the fountain, sister number 1, you go back 1 hour, she's traveling 2 miles per hour, so you go backwards 2 miles. So 1 hour, a -1 hour, and 2 miles south. So she's going to be 2 miles south of the fountain 1 hour before time 0. Sister number 2 is going to go back 3 miles. She is traveling at 3 miles each hour, but 3 miles south. So you're going to go back 3 miles north. So you go back 1 hour and 3 miles north. She was 5 miles away from the fountain, and an hour before that time, she's going to be 8 miles away from the fountain. Now you know the equation for each. The 5 is the y-intercept for sister number 2, and 0 is the y-intercept for sister number 1. So use those two equations, and to solve for x, it's going to take the same amount of time, x, to get to the same place, the house. And notice, as you solve this system of equations algebraically, you calculate the difference in these y-intercepts. So this is 5 minus 0. That's this 5 right here minus this 0 right here, which is 5. And you also calculate the difference in the slopes. The difference in the slopes is the combined rate. So that is 2 miles per hour, or 2x, minus a negative 3 miles per hour, or a negative 3x. So 2x minus a negative 3x is a positive 5x. So their combined speeds is 5 miles per hour. So they're covering this 5 miles in 1 hour because they're traveling 5 miles per hour. So x is equal to 1. That is when they both reach the house, because they've closed this gap in 1 hour. And where is the house located? Replace that 1 for x in both expressions, and you will get the location of the house, and it's the same for both. It is 2 miles from the fountain. So negative 3 times 1 is negative 3, plus 5 is y is equal to 2. The house is at 2 miles from the fountain. Or 2 times 1 is equal to 2. And again, the house is 2 miles from the fountain. So solving the system of equations algebraically is the same as just reasoning through how to get to the house. 5 miles away, this gap is being closed at 5 miles each hour. So it's going to take 1 hour to cover those 5 miles. So x is equal to 1 hour, and y is equal to 2 miles from the fountain for both sisters at the same time.